All right, so everybody understand on the first one, x's, -5 and -5 repeated, but they both have different y values. That's your automatic indication, not a function, okay? On the second one, we got a repetition here. Of course, are their y's different?
No.
Yeah. That is not a function, okay? You getting the hang of that? How to look at that table? Yeah? Okay. All right. On the third one, any x's repeat? Okay, no x's repeat. Can they have y's repeat? Yeah. Do any of the y's repeat? -5 repeats. The x's are different. That's okay. It's vice versa when the x's repeat, but the y's are different. Yeah? Does that make sense? Okay. All right, so determining if graphs are functions or not, you guys understand that part? Yeah? Make sure you put in your notes this part because, again, we already took the first quiz, okay? And the majority of you guys got it, okay?
You put no.
Oh, I put no, wait, that's wrong, correct? That is a function, thank you. Make sure you guys correct me, don't feel like I'm gonna get, I don't mind, okay? All right. Everybody okay with those three right there on the functions? Just determining if they're a function or not? That's easy? Okay. To look at the graph and see how it's moving, okay? Do you guys all have your parent function cheat sheet in your folders? If you don't, can you go ahead and grab your folders real quick? Okay. So first of all, determine if that is a function or not. So you guys notice if there's any x's that are the same, but the y's are different. Does that happen? No? All right, so yes or no? How many think it's not a function? Okay, one? No? Okay, how many think it is a function? I got a couple more, so let's double check. Any of these repeat? No. All right. If they would have, what you're looking for is were their y's different? Yeah? All right. These can repeat. It's okay if these repeat, as long as their x's are different, or they could be whatever. Okay? But the x's over here, if they're the same, they can't have different y's. Okay? So this one is yes. We're okay right there? Yeah? All right. Okay, the next one. Function, yes or no, everybody? Yes? Okay, so double check. And you guys getting the hang of how to double check? X is repeated. Oh, no, this is a -2, this is a +2. Okay? X's didn't repeat. Y's can repeat. No, so this is a function. Okay? All right. Number 3, what do you think? Everybody, yes or no? Yes? Okay. X's don't repeat. Y's can repeat here. So this is a yes. All right. Everybody okay on that first page? Just all we're doing right now is just making sure you understand. Do you just know how to figure out if it's a function or not from just looking at the table? Everybody feel comfortable with that part right there? Yeah, pretty easy? Okay. Now, the next part of this is going to be, eventually, you guys are going to have to be able to tell me what kind of graph it is, okay, from the table, all right? So one of the things that I want to do here is I want to see what these graphs look like, okay? So now we're going to do a rough sketch of these graphs, okay? Now, whenever you do a rough sketch, look at the domain. The domain has these numbers from -5, 6, -3, 17, -5. Or you guys notice that the domain numbers are just jumping all over the place? They're not in order. It should really be in, what's the biggest negative number on the domain? Every -5 is the biggest one? This table really should have been written like this. What would be next? Okay, what would be next? 4, 6, 17. This is how that table should have been written. Now you don't need to write this. I'm just trying to make a point here. Do you see this table is the exact same table as this one? Over here, everything is determined on your domain. The -50 went with 4. It's whenever you start your domain and range, your domain is your independent variable. These, the x's, they're your domain, right? But they're also your independent variable. The y's depend on whatever the x is. So notice you said, how come the -50, we didn't put it up here, right? And the reason why the -50 didn't go up here, because if we put these in order, it would switch things around too, wouldn't it? But the -50 depends on whatever the x was, because they go together. Kind of like a couple, right? So that's why this number has to match with that one always. So do you notice over here they work together? Yeah. These numbers are all independent. These numbers are all dependent. We don't know what these numbers will be until we figure out what numbers we choose for x. Okay? Now remember the very first day when I had you guys try to graph one of the problems without the graphing calculator? I told you, just do it on your own. Maybe some of you guys try to do an input-output table, and you chose x values. Okay? When you guys start doing these graphs, you guys are going to need to remember the domain and the range. Remember, domain are all your x's, range are all your y's. Now you're also going to be required to remember which ones are the independent and which ones are the dependent. And typically, your x values, your input values, those are independent. Your y values are your dependent. Okay? Here's another way to, so that you guys understand dependent and independent. Did you guys have a choice, and hopefully I don't offend anybody, did you guys have a choice on who your parents were? No. You had no choice on that, right? You guys are dependent on who they were. Whoever they were. Okay? If you have children, your children are dependent on who you're the parent. If you were the parent, your children depends on you. You are independent. Okay? Your child doesn't have a choice if you're gonna who their parents are gonna be. Okay? Alright. So hopefully that kind of brings up the word independent and dependent. Some of you guys have heard that word before, right? Dependent and independent. Yeah. Have you guys ever heard your parents say, you guys need to be more independent? Or something like that? An adult? Yeah? What are they trying to tell you that when they tell you, you need to be more independent? Do stuff on your own. What else? Not have to keep worrying about, is mommy and daddy going to do this for me? You got to figure it out. You got to start figuring it out. Eventually, your parents are going to be trying to tell you, hey, eventually you need to be able to have your own job, your own house, your own car. Remember all the stuff we talked about at the beginning of when the semester started? All this stuff is going to be coming at your face when you guys become independent. Remember? hopefully have a mortgage, you're gonna be buying food, you're gonna have water, gas, electric, cell phone, car, all the stuff that goes with the car, health, taxes, entertainment, clothes, all that stuff. If you can provide it to yourself, then you're considered independent, aren't you? Yeah? You don't depend on anybody. Right. So now I need you guys to kind of relate that with the X and the Y, okay? The word independent and dependent is going to come up on the second quiz, okay? So I'm going to start talking about that a lot, okay? So make sure you're taking notes on which are the dependent, which are the independent, okay? All right, so if I look at the graph of this problem, do you notice that the furthest value on the X is -5, and on the left, and the furthest on the right is 17? What that's telling me is the domain on the table is from -5 to +17. Somewhere in between there is the graph. But then look at the Y values, the range. What's the highest Y value in that range? Meaning the biggest positive number. 8. What's the lowest negative value it goes down to? -50. This is not an accurate X and Y graph of in units. I just kind of did the domain and range. Remember there was a question on the last quiz that said if this is the domain and range. A lot of you guys did this. Your graphs needed to start somewhere over here, and it needed to do something that it went all the way down here and all the way up here, but it had to end somewhere over here. My picture's off right here. It needs to reach all the way to the top because this is part of the range, and it needs to reach the bottom. It needs to be able to reach the bottom and the top, and it needs to be able to reach the left and the right. You understand that? Yeah. Some of you guys had the right idea because you drew the box of where it was. Dashed line meant it didn't touch it, so that was an open circle. Solid line meant it did touch it there. So that's the only part that a couple of you guys forgot about that. But do you understand it now? Yeah. Okay. All right. So this is just I just made up a graph right now. Okay. Like you were supposed to do on the quiz one. You were supposed to make one up. All right. So here's my domain and range. So the graph is somewhere in between. So check out how this is going to look. From -5 it goes to -10. So that's roughly there. And then -5 to +6, -3 to 8, 4 to 50 to -50, so that's way down here, 6 to 5, 17 to 8. So if you look at it, you guys see these dots? And remember, my scale of it is not correct. But there's points over here on the left, points over here on the right. Does that look like a linear graph with all those points like that? A linear means what? Straight line. Look at your paper. Red graphs. Very first one is a linear function, yeah? Their slopes are going to be constant, okay? Now I rewrote these in the correct order because we need to see what's happening, okay? All right. So what we're going to start to do is we're going to make sure that the table is in order first. Remember, the x's need to be in order, not the y's, okay? Is the domain in order on the second table? No. Okay, 1, 4, 6, 4, 8, no, it's not in order, okay? So you gotta make sure when you guys are looking at these tables, and you're gonna start to determine, is this a linear function, an exponential function, a quadratic function, or whatever? First thing you gotta make sure is the table in order, but the x is only. Technically, this is what should be first? Is the 1 correct? Okay, what should be next? 4, 3, and you could add 4, 15, and then 4, 3. That part, you guys understand this could have been switched? Okay. What should be next? It's negative 3, 20, 27. So this is the next step. When we start figuring out, are these functions or not? You guys understand it doesn't matter if they're in order on the domain or range. You can figure out if it's a function or not just from the table. All right. Go ahead. If there's more than 2 numbers on, if the x number repeats, but the y's are different, that's not a function. Oh, that, like I said, you could have 4, 15 first and then 4, 3, didn't matter. As long as the x's are in order. Yeah. If that was the case, then 4, 3, put 4, 3 first, because the 3 is before the 15 anyway, because they're still right after each other. Yeah. Okay. And the reason why I need you guys to rewrite them in order, because when I start showing you how to figure out if these tables represent a linear, quadratic, exponential, or any other graph, they have to be in order. If they're not in order, and you don't pay attention to that, when you start looking at the differences, at the changes in the numbers, that's going to mess you up, okay? Right. Okay, so can you do me a favor? Are there any questions on how I'm figuring out the correct order? Remember, it's the x's that matter. The y's, you don't put those in order too, because then it'll rearrange these. The x's are called your independent variable. Make sure you're putting that in your notes. The y's are called your dependent. The independents are also your domain. The dependents are your range. Yeah? All right. Is the last table on the top, is it in order? I think it is, isn't it? Yeah. Negative 11 is a bigger negative number than negative 9. I want to notice when I refer to numbers, negative 11 is over here, then negative 9, right? Technically, negative 11 is smaller number because it's further to the left of 0. The more you go to the left of 0, the smaller the numbers technically, or in real life, it's more money you owe. And that's one thing that I gotta make sure I always remind you guys. You gotta try to avoid in real life getting into negative numbers. Because then we lose our house, we lose other stuff. You know, cars are possessed. Okay? So the key when this starts to happen for you guys right here, be mindful of how much money do you make and how much money do you spend. If what you spend is more than what you make, a red flag should pop up in your mind and be like, you better hurry up and figure this out, how to balance your checkbook and balance your account. Because if the way you live is more expensive than the amount of money you make, you need to drop this big time. Because now you're going to start to get into those negative debts, and that's when people lose houses and cars and all that other stuff. Okay? Just keep that in mind, because in real life, you guys probably know people that are already starting to lose stuff. Okay? okay? Because they go more in the negative, okay? So just keep that in mind. And I'm always going to try to teach you about, because eventually you guys are going to be adults. And you guys are going to have all these things on your plate. And then if you put on top of that a family, you know, kids, that gets even more, okay? It's knowing how to juggle things, okay? And you guys growing up, maybe you guys experienced when there was problems in the house, you know, because financially things were rough, maybe. Yeah. Okay. The better you guys get at knowing how to work the numbers, okay? Okay. So we agree that the last one is in order. The x values are correct. Remember, now that's how we're going to determine if the tables are going to represent what kind of graph is it going to be. Now you guys are not going to have to do this rough sketch of them. I'm going to show you tricks on how to just do it going off of the table. Okay? Very good notes here. When you are looking at a table, you want to look at its rate of change. Okay? Now, do you guys remember y equals mx plus b? Remember this m represented what? Slope. Slope was the rise over the run. Does anybody remember the formula for slope? Way back there, a long time ago in algebra. Anybody remember it? Okay, you have y2 minus y1. Perfect. Perfect. You guys remember it now? Remember seeing that a long time ago? This is the change in y over the change in x. So watch this. What happened between -5 to -2? They went up 3. And remember, these are the 4 things you're going to try to figure out. Did they add or subtract to get from one number to the other? Or did they multiply or divide? So those are the only 4 things in all of math that you guys are doing. Okay? Is there a number that I could add to get from -5 to -2? 3? All right. Okay, now you do the next one. Write it on your paper. What is the next one? Would you add a number, subtract a number? What do you think? Add how much? Add 3 again. From -2 to 0. How far is -2 to 0? Beginning. If I add 3 to -2, shouldn't I be at +1 then? So what's the number? +2. Okay, now do the next one. The next is it an addition? Addition of how much? From 0 to 8 is, let's say, so first, real quick, this is what you guys have been doing since, I didn't realize this, but in kindergarten, that's when they've been teaching you the numbers 1, 2. I know that because my son is in kindergarten, and the teacher already gave us homework to teach him 1, 2, 3, 4, 5. So I'm assuming you've been doing math since kindergarten. That means in first grade, you already knew the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that means in second grade, that's when they taught you guys how to add. In second grade. And maybe at the end of second grade, they taught you how to do subtraction. So I'm going to assume that by third grade, you guys were doing multiplication and division by the time you reached fourth grade. Yes? Fourth grade to right now, you've been doing this. That's a long time. Okay? And just keep that in mind. All this experience with adding, subtracting, multiplying, and dividing is supposed to help you now. Okay? All right. Now, what happens there? Add how much? 12? Okay. All right, how about the next one? Add 8? Okay, and the next one? Add 32. All right, let's pause right here. All right, so you guys are going to take a look at the changes in the x's, the changes in the y's, and then we're going to look at the rate of change of the x's and y's. And if there is a constant rate of change, that's going to determine if it's going to be a linear, quadratic, or exponential. Okay? All right. Okay, well, what happened between the -2 to 0? Which one of these four do you think happened? +2? Okay. All right, then from 0 to 1, what do you think? +1? And then from 1 to 2? +1? Okay. I don't see a pattern there. Yeah, okay. Right. What happened between -17 and -1? Add 16? Okay. If you add 16 to -17, that gives you the -1. Okay. From -1 to 4. At 5? If you add 3, then I'll only take your +2. Yeah? Okay. Now, one of the things that you guys got to keep in mind is you got to keep in mind where you're at on the number line. You're going from -1 to +4. That's 5 units away. Yeah? 4 to 31. At 27? I don't see a pattern in either side. So now what we have to do is we have to do the rate of change of each one. Maybe there's a pattern there. Okay? The first rate of change is it the 2 first or the 16? 16. Remember, slope is rise over the change in y over the change in x. All right, so 16 over 2 gives us 8. Okay, so far we're okay right there. The next rate of change is going to be what? 5 over 1. That pretty much reduces to be 5. I'm already kind of heartbroken because I was expecting to see something the same here. Yeah, but maybe there's something in the next one. Yeah. Okay. The next one would be 27 over 1, which is really just 27. Right there, I know this graph is not linear. There is no rate of change. It's one of the other ones. I'm going to show you that, but right now this graph is not linear for sure. If it was linear, these rates of change should have been the same. You with me there? Okay. All right. Go ahead and try to do the next one. Can you figure out if it's a function or not a function within 10 seconds? Yeah, you already know? Yeah? Okay, good. Do the next one. Function or not a function? You guys see how easy it is to determine if it's a function or not now? You don't even really need to write anything. But for the sake of my persona is I always want you to write stuff down and take good notes, okay? In the first one, did any of the x's repeat? No. If they would have, you would have looked for different y's. So this one is a function, yes? All right. In the second one, any x's repeat? You know, almost, and then they made, but those are not the same. They're 16 units apart. These numbers, doesn't matter. So you kind of get an idea of as long as the x's, it doesn't repeat with different y's, then you're pretty much going to be most likely at a function. Okay. All right. Now, let's try to figure out if it's linear. Yeah, can you figure out if it's linear? Try to give me enough room so that I can keep going if it's not linear, though. All right, so everybody starting to get the hang of how to get these, figure out plus. Remember, it's only 4 things. Add, subtract, multiply, or divide. You got to figure out one of those 4. Okay? All right. And when you look at these points, when I plot them, can you see the parabolic curve that it's starting to form? Yeah. Okay. So if it's not a rate of change on the first one, but there's a rate of change that's constant on the second rate of change, that makes it a quadratic. Yeah? All right. Did you guys do this one already? Yeah? No? All right, go ahead and take a minute. Was there anything from negative 16 to negative 8 that you got? Plus 8? All right, how about the next part? 4? Plus 4? Okay. Next one? That's 12? Okay. I don't see a pattern there, yeah? How about these two? 6, yes? Plus 6? And how about these two? 3? How about these two? Plus 9. Okay, no pattern there at all, right? Okay, you see some pattern, but you know what we didn't check? We didn't check if they were in order. That's the first thing we got to remember. We got to make sure if it's in order. If it's not in order, it's going to mess us. It's going to mess us up. Yeah. So let's go ahead and do this real quick. Let me just write it over here. What should be first? Is it? Oh, okay, yeah, it is in order. So that was what? How much? 8, 4, and 12. Okay, so that was in order. Okay, good. We always got to make sure that it is though, because if it's not, our rate of changes are going to be off. Okay. What did we say there? 6, 3, and 9. Okay. No pattern. Now you got to go on the change in y over the change in x. Okay. 6 over 8 reduces to be what? How much? 3/4. 6 and 8 are both divisible by the number 2. 6 divided by 2 is the 3. But you also got to do the bottom divided by 2. Okay? You can't use a different number on the top with a different number on the bottom when you're reducing the fraction. You can't say, oh, well, I'll divide the top by 3 and the bottom by 4. You can't do that. It has to be constant. Okay? All right. Can I reduce 3 over 4 anymore? No. Okay. What's the x rate of change? I like that. We just need to make sure the next one has to be that. If it is, then you already know something, don't you? Yeah? Okay, what's the other one? 9 over 12. All right, let's pray that we can do this division. What can I divide the top and the bottom by? Say 3. What does that give me? Damn. Is there a pattern there? Did the same thing keep happening? Yeah. So now, because the rate of change, and notice I haven't done the second rate of change at all yet. The first rate of change makes this automatically what? Linear. What if the first rate of change there wasn't any, and you had to do the rate of change of the rate of change? Then that would have made it a quadratic. You getting the hang of that? Yeah? Okay. So linear, you feel comfortable with it? Now you start to feel comfortable with quadratic, how to figure it? Yeah? I'm going to show you how to figure out the actual equation of these by just doing this. That means if I can show you how to get the equation of it, you can actually graph it, can't you? And then you can actually tell me the domain and the range it has asymptotes or anything. Yeah? Okay. We're okay so far? If everything feels good, you guys are taking good notes. That way, if something happens, you know, on the quiz next week, you guys can go back to it and stuff. Yeah. I forgot. I had to get the pattern of the pattern and then get going. Yeah. Everybody catch that part? I almost kind of messed it up right there. Yeah. Okay. All right. So you notice that this is a quadratic equation, has a y-intercept that's 0, -2, and it looks like the parabola is going up. If you look, notice when 5, it goes up, positive. Over here, these numbers. It has a y-intercept at -2. Okay. All right. All right, so I'm going to give you guys about 5 minutes just to finish those problems. That's 8 of them. If you're not sure, type it, graph it, put it in your graphing calculator. And all you're determining if it's a linear, quadratic, exponential, absolute value. Absolute value, again, always looks like a V. Okay? All right. So take 5 minutes. And see, land and finish where you're at. While you're doing that, I'm going to type in the first equation. All right, the graph of the first equation, y = x - 3. Everybody agree that that is a linear function? That's the equation of it. There's my equation typed in, y = x - 3. Yeah? Okay. So that is a linear function for the first one. You could draw a rough sketch of it if you want to right there. And if you notice, it touches the y-axis at -3. And it looks like it touches the x-axis at +3. If you wanted to get a rough sketch of that. Okay. All right, the next one is y = 7x squared. And y = 7x squared. I already know that that's a quadratic. Everybody see the graphing? So you see the graph. And you guys see the quadratic, it's at the origin. It's just a little tighter than normal. Remember, this number is going to make it narrower. The bigger it gets, the more narrower it's going to be. The more it looks like a fraction less than 1, it's going to make it wider. Okay? All right. Make sure you draw a rough sketch of that one. That's a called a what? Quadratic or an even powered even degree polynomial. Okay. Right. Clear that one. All right. The next one is, you notice it's written as a ratio of 1 over. Is it an odd number power on the bottom or an even number power? That's x to the 1, right? 1 is odd or even? Odd. So it's 1 over an odd number power, which would make it the 1 over an odd power, which would make it this. Yeah, okay. So let's go ahead and type in y is equal to 1 divided by x. All right. You guys notice it has asymptotes on the y-axis and the x-axis. Those are never going to be touched. Okay. Everybody okay on that one, and how to draw a rough sketch of that one? Okay. All right. Next one is y equals absolute value. Now, did I show you guys how to get the absolute value? If not, okay. Second 0. When you get to catalog, the first one is absolute value. So you hit enter. And now you see the absolute value symbol. And now we can type in x plus 1 and get out of it. Yep. Graph that. Absolute value functions are always going to be V-shaped. If there's a negative outside the absolute value, all it does is just force it to go down. Okay? Everybody okay with how to type it in? Okay. That's an absolute value function. Okay? All right. The next one is just y equals 5. So it's just y equals 5 like that. Only on the graphing calculator can only be graphed when it's in y equals format. That's in function notation or f of x equals. Do you notice that's a horizontal line? Okay, that is a function. If you notice past the vertical line test, every point only touches once. That's the other way to tell if something is a function or not. Vertical line test scanning from left to right, does it always touch the graph only one time? If it ever touches twice at the same point, on the x value, remember, if the x value has 2 different y values, that's not a function. Yeah? Okay. All right, the next one is y equals, but you notice it's written the x minus 2 where the exponent would be. So you would type in y equals 3 caret button parentheses x minus 2. Close your parentheses and then get out of the exponent. Okay, did everybody see how I typed that in there? No, you want me to do it again? Yeah, okay. All right, here we go. First, we got to get the 3, right? So y equals the 3. Is it right there? Okay, when I say the caret button, that's like the chevron symbol right here. Press it once. Okay? Notice it took you up to the exponential part. Put the parentheses though, because you only want x minus 2 to be as an exponent. Okay? If there was anything that went after it, get out of that exponent part, because now if you stay up there, it'll assume you're raising it to that power. Okay? All right, so when you graph that, exponential growth. Okay. Questions on there? You notice number 7 also is going to be an exponential growth. Just the shift is going to make it go down 7 units. Okay, so let's do the y equals. We're going to clear that. 5 to the x power, and then you have to get out of this. If you don't get out of that part of the exponent, you don't assume that you're saying x minus 7 as an exponent. Yeah? Then you hit minus 7. And that's an exponential growth. You've shifted everything down 7 units. it's going to have an asymptote somewhere around here, horizontally, because it looks like it's flattened out right there. Number 8, you notice that's also going to be exponential, but it's not a growth, it's going to be a decay. Let's take this back there, so. Okay. So go ahead and type that one in. Clear it. Okay, we're going to type in 6 minus x squared. Oh, wait. I got that wrong. That is a quadratic. I didn't pay attention. That's really why it's negative x squared plus 6. That was really off. Almost caught me right there. Does that look like a quadratic then? When I rewrote it like that? No, that was, I almost lost that explanation. No, it's not exponential, it's quadratic. Caught me right there. All right, everybody okay with those that we've done so far? All right, so on Thursday when we come back, you guys are going to, right off the bat, when you come back, when you come into class, you're going to start telling me if they're functions or not, yeah? Okay. All right, so go ahead and put your handouts away. Put them in your folders. You don't have any homework to take, okay? But when you come back on Thursday, first thing you guys are going to do is that next page, okay?